What's up, it's Carter, and this is our Week 3 Automotive 240 video. In this video, we will talk about throttle position as well as different temperature sensors. The cars referenced in this video include a 2017 Buick Encore, 1999 Acura TL, and a 2006 Toyota Corolla. We will be demonstrating different tools and readings between similar sensors on these vehicles.
My name is Aiden, and today we'll be going over throttle position sensors, engine coolant temperature sensors, and how to use the scan tool, picoscope data, and showing you how to backprobe the connector to get that data. Here I have a diagram of the throttle body for this Buick, and our two signal wires are going to be 485 and 486. Those are our two signal wires. And going in here, we can see us backprobing that connector, and we have it ground straight to the negative terminal of the battery. And with this, we can see our testing with the two lines. One's going to be a positive, one's going to be a negative, following each other to make sure they both work properly.
This is our live scope data we got from the 2017 Buick Encore throttle position sensor. The results from this are similar to what the scan tool had shown. The scope data more accurately depicts how voltage is changing between these two inputs. Here we are demonstrating how you can use a multimeter to get a reading from the throttle position sensor. As you can see from this photo, the ECM is commanding 2.4 volts while the car is at idle. We also use the live scope to measure the ECT. As you can see in the video, we set our range to measure from 0.5 volts up to 5 volts. The scope data shows how the voltage of the ECT signal wire stays around 1 volt with short spikes while the car is at idle.
So here I have the scan tool connected to the OED2 port on this Toyota, and we're just showing you the coolant temperature sensor and how it slowly rises and makes a nice graph in the scan tool, showing you that the temperature is going up and roughly what the temperature is on the system.
Here we are using an infrared thermometer to get a reading near the ambient air temp sensor. As you can see, the sensor should be around 70 degrees Fahrenheit. We can then compare this to scope data and see how the vehicle makes changes for this value. As you can see from our scope data, the vehicle is calculating that it is about 24 degrees Celsius or around 75 degrees Fahrenheit. This shows how the vehicle is able to calculate average temperature during a trip and control certain engine conditions based on that value. Here you can see how things like engine temperature can control certain conditions such as spark advance. We hope this video does a good job of depicting how sensors on different cars can be used by manufacturers in the same way. Our goal of this was to show how you can use different devices while diagnosing to locate an issue. We also wanted to define how readings from different devices may differ results and how you can use those results to locate and correct a problem.